2019 Ford F-150. It's got a intermittent fuel pressure sensor code P0451, and the description: Evap system pressure sensor switch A circuit range performance. When you come down underneath the vehicle here, especially during winter time, look, covered in snow, full of water. The water drips from the bed area and stuff right down on top of the tank and fills this area with water. That's one of the things that can cause these types of codes. Pull the vehicle inside, you let it warm up, let all the snow and stuff melt off of it, blow a bunch of air and stuff up in there and blow all that crap out. And you know, most of the time in a situation like that, it'll make it go away, because it causes the whole head of that evap, fuel, all kinds of erratic issues. Those connectors are just full of water. It's, you know, 36 degrees, 30 degrees, 32 degrees, 38 degrees, melting, freezing, melting, freezing, melting, freezing, and it just freezes all that stuff up in there. You know, it's the type of region we live in and the atmosphere we live in. It's our climate here, and unfortunately this is one of those situations where the customer is going to get charged for something that could just be a simple blowout and clean. It'd be nice if somebody could make a little plate, so as that water fell off the bed right there, it would deflect off of it and not onto the top of the fuel pump evap line connection area. It is what it is. You know, somebody was in here before. Look at this one. This is a F-150. It's kind of funny. This is a 19 F-150 with a 2.7 that has those evap issues because of that water and that ice and snow and stuff on top of all the connections on the fuel pump. Then this over here is a 17, same color STX, and it's got the door latches and stuff freezing after the shielding and stuff's already been done. I'm having to go back through and redo it all again, because the fix for it doesn't actually fix it all the time, and I'll show you guys how I do my fix. Look at this right here. Whoever did this shielding recall before and put these water shields in here, you see the black plastic right there? And they went ahead and slit the little grommets, so this has more room here to move up and down and not freeze and attach to it. There's no gasket left on the top at all. Look here on the bottom. Watch this. That's the gasket material that's on there. So they put the wiper clips on there, they put the shield and stuff in there, but they never got the gasket and stuff to sit back on there right. So all that water getting down to this door, freezing these the latching components back here. So after I get done putting the foam blocks in that Ford wants me to put in this channel, reference my older videos for the full how to do it, they'll have you run a sea of foam around here, and then they'll leave this part open because it has to clip up behind there, and then you got to silicone it. I silicone around the whole piece, a little bit on top of the foam, so whenever I seal this and push this up in there, it dresses up all the way around the handle. And not only is the foam sealing it, it's got a fresh thin seal of silicone that also seals it, so that handle will never leak again with water inside there. Now, something interesting that happened with the 127 with the snow and the water and everything on top of the connections, even though we had a theory that that was causing an issue, after clearing all that off of there, it didn't actually cause the issue. What was the issue was the vapor blocking valve that's in between the tank and the purge valve. Whenever you would run an evap test, it would stay open and it would pull vacuum on the tank, and it would actually pass the test. But whenever you were actually looking at the system and opening the purge valve and closing the vapor blocking valve, it was still pulling vacuum on the tank, which in a closed position should not be doing it. Which means that even though it was faulty and malfunctioning in the open position, no matter what, it failed, even when it said it was closed or it said it was open, it was always open. So it never had a reason to really trigger that there was something wrong until it was so far out of the limits that there was so much vacuum being pulled on the tank that the actual fuel tank pressure voltage started acting erratic. So it needs a vapor blocking valve. So when you test the VBV individually versus the entire evap test, it fails it, because it says it closes it and still continues to pull vacuum on the tank, which is causing the fuel tank pressure readings to be erratic. So the vapor blocking valve was actually bad. So you run the test individually. Run an evap test, it'll pass, and then turn around and run a VBV individual system toolbox test on the VBV. It'll say that it closes, but you'll notice it keeps pulling vacuum even though that it closes, which is not normal. The VBV fails, even though it says it's good. It's not. You can watch it pull a vacuum, but it says the valve is closed. Well, if the valve is closed, it would have never been able to pull a vacuum on the tank. Interesting stuff. How you can be led the wrong direction if you don't know the systems and how to test them correctly, even when they're trying to take the detective and throw them off and push them another way. Y'all be blessed. Take care.